Welcome to our lectures on the DC microgrid and the control. Today we are going to discuss previous few discussions was based on your in general microgrid, and we try to cover some portion of the AC microgrid, so that you can understand with the comparisons what are the different microgrid architecture it would be. And today we are going to discuss in detail the DC microgrid architectures and its interface with the AC systems. So, it is a continuation of the previous lectures. Students are requested to go through the another previous lectures, then only he or she can understand the correlation better. So, issue is that over the last few decades, most of the commercial individual such as office loads, that means these are desktops, laptops, lighting, these are LEDs and so on, are internally supplied by the DC voltages. You may have a big LEDs TV that internally supplied by the DC supply, and thus what happened, these devices are interfaced with the low voltage AC networks through the appropriate rectifiers generally, otherwise you may just convert into the AC to DC by the rectifier, and you will inject, say that will be a 6 pulse converter and thus you will inject sufficient amount of the harmonics into the system. And for this reason, nowadays we are putting a restriction, once you are converting AC to DC, you have a limited amount of the restrictions on the THD also, and thus not simple diode bridge rectifier cannot serve the purpose. Therefore, using low voltage DC network normally result in simpler and more economic connections of these loads, and consequently enhances the network efficiency rapidly. Please understand that there are many disadvantages of the harmonics. Once you converting the DC to AC to DC, then you are throwing lot of harmonic into the system, and those harmonic will derate every component. Your cable rating, power handling capability of the cable required to be derated, your transformer required to be derated. So, for this reason, and it may cause also it may cause the interference with the communication network, as well as it may cause the oscillations into the power system, because you may have a natural frequency of oscillation that is close to the 7th harmonic most of the cases, because you have mostly you have a capacitor bank, and thus you have a leakage reactance of the big transformer, and that gives you the natural frequency of oscillations. If somehow when you are converting AC to DC, so that, and you know that if it is a 6 pulse converter, predominantly you have 6 n plus minus 1 as a harmonic, and then what will happen, those harmonics, if the component of the 7th harmonic is quite high, and that it is close to the natural frequency of the oscillation of your network, then it may cause the resonance into the system, and ultimately power in the main circuit will be due to the 7th harmonic, and you will have a lot of problem due to that. There will be a ripple, there will be a torque ripple, ultimately your synchronous machine will not be running, and ultimately you do not feel able to fit power to it, because you know sin V sin m omega t integration over 0 to 2 pi into I sin n omega t d omega t is 0 over the period. So, thus you may not have any real power transmission, because you have a 7th harmonic, here it is a fundamental and you have 7th harmonic. So, those are the and thus you just get a oscillatory power. So, those are the very big challenges, and for this reason we are putting a lot of restrictions on AC to DC conversion, and it has to be done through the proper rectification process, where you will be injecting a low THD. But that is not always feasible also, that I will come little later. The network that is supplied by voltage below 1 kV is called the low voltage network. Mostly we have 220 volt RMS as DC as AC, and we will have a same DC voltage, we can take it as a most of the cases, or we also have a 48 volt battery system can be considered as a reference. Moreover, to convert the existing AC network to a DC grid, the maximum value of the AC grid can be selected as the nominal voltage of the HVDC system. That has got a huge advantage. So, if you take a maximum current handling capability of this DC, where it will be root 2 times higher. So, current handling capability for it will be more, and LVDC distribution system constructs of power electronics converters and the DC link between these converters. The topology of LVDC distribution system can be different kind of variation. We shall discuss in detail what are the different kind of variations of the of this LVDC distribution system. And common to these different topologies are that AC to DC conversion is always located near medium voltage or the MV line, and the DC-AC conversion can be instated to be located at the different location. So, these are few issues, and so you have to take that power from this point of conversion to the point of load, and thus we have a different kind of topologies. So, HVDC distribution system topologies, depending on the location of the LVDC system, can be either HVDC link kind of solutions or a wide LVDC distribution district, where the DC-AC conversion is made at the consumer end. So, that is something we require to understand it. The wide LVDC distribution district can be compared to the existing LVAC network topology with multiple branches. That is something we require to keep in mind. So, we can have a different kind of load, we can have a different kind of voltage level, and thus we can have a branched out. We may have a same voltage level, but for example, in our household application also we have a different line, 6 ampere line and the 15 ampere line. So, in a 15 ampere line you can connect generally the power load, and the 6 ampere line you connect generally fans, lights, this kind of light loads. And for example, this kind of aspects would be there in case of the LVAC DC system, and thus we can have a different kind of topology that will, I am coming to the next slide. In this case, there is no need for the separate 3 phase 3 wire. So, you do not have to have a you require to only the return path, you need not have to have the 3 wire system, because AC line have been replaced by the DC line and no neutral can be used same way. So, for this reasons, this is the one of the architectures. You got conversion AC to DC from the main grid, and there you will ensure that your THD is quite low. Thereafter, you are transmitting with the DC, and you may have a household AC because of the historical reason, and thus you are reconverting to DC to AC, and that is better because you know what happened, you might be knowing that you are running this inverter fed ACs, as ultimately its input is been rectified and then fed into the DC, and then it has been reconverted into the AC as required by the source. So, for this reason AC to DC conversion system most of the modern load incorporates by itself, and same way here also. So, these are the few examples of the white LVDC distribution system, and one of the aspect is that it has a predominantly inductive loss, and in a multiple point you do not have a problem in the grid, that is the power quality that has been addressed here. So, no power quality problem because the entry point of AC to DC here what you do, you ensure that THD and the power factor is good. So, the white LVDC distribution district can be compared with the existing low voltage AC network branch topology with multiple branches. In this case, there is no need for the separate 3-phase network because the AC lines have been replaced by the DC lines. And one of the advantages is that power handling capability of the DC is more, because due to the skin effect, generally once you got a skin effect you have a harmonic, that is what I was saying, that harmonic if you have a sufficient amount of harmonic, you require to derate your converter, you require to derate your cables, you require to derate your transformer. So, for this reason this aspect does not arise when you have your direct DC transmissions. The LV-DC distribution system can be made with the two basic implementation, that is unipolar, it is 0 to 200 volt or 0 to 48 volt, or bipolar, then it is actually 3-wire connections plus 0 negative. The unipolar system has one voltage level by energy is transmitted, all the customers are connected to the one voltage level, and in case of the bipolar, you can do little bit of power balance, you can connect a consumer to the negative and positive loading, negative and the positive voltage bias. So, the AC grid systems, the power from the utility side can be transmitted using 2 wires for the single phase and 3-phase 4-wire system for the 3-phase with the neutral, and the power in the DC grid can be transmitted using similar configuration 2-wire unipolar and the 3-wire bipolar, and in this case also you can see the considerable amount of the copper stepping because you do not require the 4th wire. The difference between these two DC grid configuration is that number of the available voltage level, and sometime in modern it prefer the bipolar system because you can balance your loads. A unipolar DC system source and loads are connected between the positive and the negative pole of the DC bus voltage as illustrated in this figure. This is a unipolar DC configuration. You have a step down transformer, and thereafter you have a interface of DC to AC, and thus AC to DC conversion, and thus you got a DC voltage, and this is your the blue line is the 0 potential line, it has been considered. Again you may have a wind turbine that will be converted into the DC and will be fed the same power into the DC bus, and you may have a solar with the MPPT tracking and same scaling and or boosting. So, you will get the same voltage, and these are your AC to DC application. It may be the adjustable speed drive. So, you can apply VYF or vector control for the better efficiency and the better utilization of the torque, and you may have a DC load. This can be the LED, you can bypass your different kind of entities, and this is your fuel cell. Fuel cell generally transmit power. So, power it will go to this bus, and also you got a battery that will be the bidirectional. You can, and of course, generally battery will be interfaced by a DC to DC conversion with the bipolar in nature. And if you strictly maintain the battery voltage, at 48 volt, then maybe a mechanical switch can operate. One you can see that simple diode can operate, because charge can flow from this way, and once it is on, you can turn on the mechanical switch to charging, and for the discharging you can also take it a different path generally, but in general to control actively we require to put a DC to DC converter in front of the bidirectional DC to DC converter in front of the battery also. The energy is transmitted over the DC bus at one voltage level. Therefore, selection of the DC bus voltage in this case is the key for the total designing. Whether you will have a 220 volt RMS voltage, whether you will check same thing, whether you will get a 48 volt, since battery will be around that voltage level. So, that we have to carefully calibrate and see. Now, there is a two thing, once you try to send power, high power always you will find associated with the high voltage. We generally require to send high voltage once you are operating with the high power, because if you have a more current, then what happen, to send more current, then thickness of the copper required to increase and other issues will be there, magnetic effect. And for this reason we generally also try to send, and thus losses will be more, and for this reason once you are sending big amount of power, voltage also required to be high. And for this reason we are saying that higher voltage level increases the power transmission capability of the system. It is V square by R, simple. So, if you increase the voltage, it will be square of that will be the power rating, but it demands more DC to DC converter. The link can be used for more transmitting more power, but you may require different level, because ultimately the utility cannot take that particular voltage level, and thus you require to put a DC to DC converter to step it down. And operation of the DC to DC converter is unlike the transformer, it is a little complicated because the switching is involved, and it is not a dumb device like a transformer that it works on the windings. So, it has a losses, it has also its operations, and it is required to be actively controlled, and thus it associated with the costs. And for this reason we require to optimize the voltage level and the requirement of the DC to DC converters in order to match the end user voltage level. Furthermore, the higher voltage level can possibly increase the safety risk. So, one can get a shock, and insulation has to be proper, those issues also there. For example, in USA they handle with the more current, even though they anticipate better loss, they say that you design this motor better, but we are going to send power at 110 volt instead of the 220 volts, so that you do not get a shock, or that shock will be less severe. With a low voltage level, the transmission capability of the system is limited to the short distance. So, you require to have a small distance to cover, otherwise if you are sending a big power, then power losses, current big power and voltage is less, automatically current is more, and thus you will cause a huge copper loss in the DC system. So, for this reason the proper selection of the low voltage level can avoid. So, you have to match these two conflicting conditions, you the voltage level can avoid the deployment of the large number of DC to DC converter in low power grid equipments, but also you incur more copper loss. The unipolar system is viable of the off grid houses in remote rural areas where no utility grid or infrastructure exists. For example, you make a resort. Previously resorts was running with the DGs. Now you can reduce the usage of the DGs by the solar and wind. You may have a resort of plenty of winds may be there. So ultimately you can with the battery DGs and those systems, if you are running it that kind of resort and it is eco-friendly resort. So in that case you will have a unipolar system, that is better if you do not have any grid connections. And recently 48 volt unipolar DC system has been implemented with the integration of the PV panel in the microgrid of the off grid houses in the rural area. If you just I have said in a in our initial lectures that first microgrid was mostly DC and that was implemented in the Sagar island in West Bengal, that where actually Ganga Sagar pilgrimage takes place. So, that to taking because there was a no load most of the season, but only there is a load in the Makar Sankranti. So, to address those case first installation, but there was a it itself is a big case study, it was a case of failure though, but from that installation we learned lot of experiences and that has been taken care of in our previous installations. The unipolar system is simple to implement and there is no chance of having any asymmetry between the DC poles. That is something you have to keep in mind. So, that is a very big advantage of using the, and if you have a more positive load and the negative load, the neutral point, that is the zero potential point what you are saying, it will shift something like the neutral point of your transformer and you got a high current will flow. So, same way will happen here. However, system does not provide any redundancy. If the power goes up, one line is goes out, so its power is going into by the single line. In some way that has been disturbed, so ultimately you have to leave without power. And therefore, a single fault can lead the shutdown of the total complete system. That is the vulnerability and we require to have a protection. I shall discuss protection in detail in later side. Protection also DC microgrid is a very big challenge because you do not have a natural 0 here. Moreover, this system does not offer different voltage level options to the customers. So, that is also one of the disadvantage and thus we require to use many DC to DC converter either step up or the step down the voltage to meet the requirement of the particular load or the energy resources. And whereas you have a bipolar DC to DC bipolar DC system known as the 3-wire DC system, which consisting of the plus DC and the minus DC and the neutral line. So, you have a AC grid, you have a step down transformer, you have the AC to DC conversion system and this is the bus, and here you can see that this is red line is a positive bus and the blue line will be the negative bus. You have a bipolar all those things and in between you know what you do, you generally make it. So, you will ground this is something like this. So, your VDC this will be your plus VDC. So, this will be your high voltage and this will be your low voltage and this potential will be 0 and you will have a bipolar line. Other lines are same, but while in this configuration you know it does not require the 0 potential, but here it is a wind turbine, here it is maybe it is a battery, but you may have a DC load and you can see that you will configure accordingly. You have a adjustable speed drive, you have a AC DC DC. So, generally you will give plus minus and that will be converted into the AC. And if you have a DC load, generally you will pick up positive and the negative, and you have a redundancy once if some way this line is cut off. So, you can manage to operate and you just switch over this point to negative terminal. So, same way for the DC load you will be connected here, and to balance the load some load will be connected negative to positive, negative to positive. So, these are the case. So, in that way you try to balance and also you provide the redundancy of your loading, that is called the bipolar system. In this configuration, customer have the option to choose that 3 difference voltages, that is also one of the important aspect. You can choose plus VDC, minus VDC as well as the 2 VDC. So, for the high power rating you can feed from the 2 VDC just as we are feeding from the adjustable speed drive for the higher DC link voltage. And furthermore, under fault situation one of the pole of the DC may go out and ultimately you continue to feed with the another pole. The power can be still supplied with the other 2 wires and an auxiliary converter. So, we require to change one maybe something. Therefore, reliability, availability and the power quality of the systems are increased during the fault condition. Also it better for the handling the if the power of the few converter is more. Now, the different voltage levels offers more flexibility to the customer in order to connect different loads, but at the same time this can result unbalance in the system. That is what I was saying that this is a DC unbalance, you might be not aware of it. So, we had talked about the AC unbalance. In one phase you have a more load, another phase you have a less load, but here you have this problem. Let us see how we can address, but at the same time unbalance in the system due to the unequal distribution of the load, some because you are connecting the positive DC bus to the negative DC bus voltage, maybe the load less load and the reverse may have the more load. Then you will find that the point which is taking the more load will shift your 0 voltage level. That is the one of the disadvantage of it. Therefore, the voltage balancer circuit or the suitable control system of the power converter at the source sites is highly recommended for this type of system. So, you require to be provide that equalizations, otherwise you have a floating problem we generally say. The unipolar and the bipolar topologies are the basis of the future architectures of and the grounding scheme of the DC microgrid, and grounding scheme also we require to change, because as we can see that we had a AC grounding and here and due to this positive negative your ground and maybe you have a loading scheme is different. So, you require to have we require to balance it, and for this reason we can also work with we have a different kind of balancing scheme. Please remember, in a neutral point with a solid grounding, there with a resistance grounding, we got a capacitance grounding, we got an inductive grounding. Those option is not there, because if you put a capacitor it simply block the voltage, and if you put an inductor it simply short circuit it will not allow unless there is a change in it. Sometime here also we introduce the inductive grounding, that is the total scope of the protection system of the DC microgrid. That itself is a very big challenge while addressing the microgrid, DC microgrid. Thank you. I just revisit few aspect for your reference, that is unipolar PWM are simple and are being preferred for the low power level system, but where you require the more redundancy, more reliability, and where you require to have a more power to be fed. So, 2V level of the voltage is quite suitable, and for this reasons consider the DC microgate in case of a mall or maybe a ship or whatever maybe, or a small isolated island. In that case we prefer a bipolar kind of power supply. But bipolar kind of power supply will have a problem that the load connected to the positive DC bus and the negative DC bus will be different, and for this is what will happen, what you are saying 0 potentially it may not be a 0 potential, and you have to actively make it 0 by maybe shifting some amount by load adjustment or what, or the by the control technique. So, these are the extra effort you require to put in this case of the bipolar DC microgate. Thank you. Thank you for your attention. I shall continue with the DC microgate in our next class also.